This short film traces the development of the School of Physics and Astronomy at the University of Edinburgh from very early days up until the present, and reflects on the achievements of some of its students and staff. First port of call is to Professor Sir David Wallace.
I'm in the house where James Clerk Maxwell was born. It's 14 India Street in Edinburgh's new town. He was actually brought up in Galloway and then returned to school in Edinburgh, where he earned the nickname Dafty, but no Dafty he. He enrolled at the University of Edinburgh in 1847 and went on to an extraordinary career, which has labelled him as one of the greatest physicists of all time, not just the 19th century. What was then called natural philosophy was in the centre of town until 1971, first in Old College and then in Drummond Street. I actually enrolled as a student in physics in 1963. My scarf of more than half a century ago to prove it. But experiment and I didn't get on, and I changed to mathematical physics. The right degree for me, and wonderful lecturers. I did a PhD subsequently with Peter Higgs in the theory of subatomic particles. At that time, the Tate Institute of Mathematical Physics was a separate department, housed across the road in 1 Roxburgh Street. Nobel laureate Max Born was head of the institute from the 30s into the 50s. Before him it was Charles Darwin, son of the great naturalist, afterwards Nicholas Kemmer, and then I was appointed in 1979, and the post is currently held by Richard Kenway. Of course, Edinburgh also has a long and extremely distinguished tradition in experimental physics. Charles Barkla was appointed as a professor in 1913. He won the Nobel Prize for his work in X-rays. His successor, Norman Feather, was appointed in 1945, and he expanded the work of the department into nuclear and high-energy physics. In the late 1960s, natural philosophy was renamed physics, and it subsequently combined with the Tate Institute and with astronomy, and is now the School of Physics and Astronomy. It's housed in the James Clerk Maxwell building, at the King's buildings, with astronomy up the hill in the observatory. Bill Cochrane's appointment to a chair in 1964 sparked a whole new era of research in condensed matter physics. Extraordinary quality of people. Many of them went on to become Fellows of the Royal Society. It's now the Institute for Condensed Matter and Complex Systems, and does a huge range of work, including, for example, the fluid dynamics of microbes.
Stuart Pawley was appointed to a personal chair of computational physics.
Digital computers were becoming a very important tool for the physicist in about the 1960s. That was the time when I became appointed at the Department of Natural Philosophy. In the early days, I used computers for molecular dynamics, but then in 1980, I wanted to work on simulations of molecular systems, and I started to work on the computer that we called the distributed array processor. This computer was essentially the first commercially available highly parallel computer, and here's a board from it. It has on it, you can see 64 processors on this one board, and with 64 other boards, the computer had 4,096 processors which all worked together. The total calculation I used for my thesis over about a year could now be done in less than a nanosecond on one of these computers. Our work in parallel computation led to the establishment in 1990 of the Edinburgh Parallel Computing Centre by David Wallace. This allowed us to do a very wide range of computational problems. The EPCC now runs this facility, which houses some of the most powerful computers in Britain and allows us to do parallel computation on a worldwide scene.
Professor Alan Shotter joined the school in 1970 and took over as head of the nuclear physics group.
Norman Feather was appointed to the chair of natural philosophy in 1945. His research expertise was in the area of nuclear physics. Together with his many students, he used the cloud chambers to investigate the ionization processes of particles traveling through gases, as well as using this technique to investigate nuclear reactions initiated by alpha particles and neutrons. This is an example of an early cloud chamber, now in the National Museum. These early experimental studies in nuclear physics were made with modest size apparatus, such as what could be fitted on a bench top like this. In fact, the cloud chamber could easily be fitted on this top of this bench. But it became clear in the 1950s and 1960s that if we were to progress in our understanding of nuclear physics, then much more large-scale apparatus would be needed. Recognizing this need for more sophisticated apparatus, Norman Feather obtained funds to purchase a Cockcroft-Wharton accelerator, which was housed in a purpose-built building in the courtyard of the old Natural Philosophy Department in Drummond Street. By the time I was appointed in 1970, it became clear that if we were really to probe even greater depth into the physics of the nucleus, even larger scale facilities would be needed. But such facilities could only be constructed and exploited if collaborative teams across national boundaries came together to promote this research. I was given the mandate to develop a research group that would spearhead these national and international collaborations linked to these forefront facilities around the world. Over the decades, Edinburgh staff and many students from Edinburgh have collaborated with physicists from all around the world, most countries of Europe, USA, Canada, Japan, China, and India. This is an example of one of these international collaborations that Edinburgh has actually been in. This is a laboratory in Canada. It's the National Laboratory of Particle and Nuclear Physics of Canada. And this is the accelerator complex, and in that complex, Edinburgh has got an experimental station where physicists from Edinburgh, in collaboration with other international physicists, can conduct experiments, and they have been doing this over many years.
Murray Campbell was a student in the school and was appointed Professor of Musical Acoustics in 2000.
Applied physics at the University of Edinburgh was pioneered by Dr. Marion Ross, who was a former research student of the Nobel Prize-winning Charles Barkla. During the war, she was seconded to the Admiralty and became interested in fluid flows, and in 1969 she set up the Fluid Dynamics Unit here at Edinburgh. In the early days, research was centred around a low-speed wind tunnel in the Drummond Street building. Experiments were carried out on boundary layers and also on more applied topics like wind turbines. After the retirement of Marion Ross, emphasis shifted towards the statistics of turbulence and also to study of dynamics of water waves. A number of flow channels and wave tanks were constructed for experimental purposes, and also optical flow measuring techniques such as laser Doppler velocimetry and particle image velocimetry were developed. In 1983, there was another development in applied physics, the formation of an applied optics group. And that group did work on the development of optoelectronic sensors and devices such as spatial light modulators and liquid crystal displays. More recently, there's been an important development in the study of complex systems, disordered matter and complex fluids, with applications in the life sciences. The James Clerk Maxwell building contains two spaces which were specially created for acoustics experiments. I'll take you into one of these now. As you can probably hear, this is the reverberation chamber. No parallel surfaces and a very long echo time, approaching 10 seconds at low frequencies. In contrast, here's the very dry acoustic of the anechoic chamber, the walls, ceiling and floor covered by sound-absorbing foam rubber wedges. These rooms were both designed by Marion Ross, and their availability here led to the development of an interdisciplinary collaboration in acoustics teaching and research between physicists, engineers and musicians.
We're now going to the Royal Observatory, just close to King's Buildings, to meet Professor Peter Brand.
Astronomy has been pursued at Edinburgh University since 1583. During that time, it's experienced a number of major changes, one of which was the completion of the Royal Observatory on Calton Hill. Another of which was the move to the present observatory on Blackford Hill, where for a time it continued to regulate the firing of the 1 o'clock gun at Edinburgh Castle. Originally in the hands of mathematicians, the subject has moved ever closer to physics, and over many decades, successive directors have given courses in astronomy for advanced undergraduates of physics. I graduated from such a course, and I'm standing next to the telescope on which I did my postgraduate work. Nowadays, it is just a monument to past spectroscopic work at the observatory, as young astronomers nowadays use large facilities in Chile and Hawaii, or indeed in space from satellites. My postgraduate research was a small part of the wave of innovation that started in 1957. The computer control both of measuring instruments and of telescopes was pioneered here under the brilliant direction of the 7th Astronomer Royal for Scotland, Herman Brooke. The leading position of the Royal Observatory in this area continues right up till today. It's involved, for instance, in developing parts of the European Extremely Large Telescope, which will have a diameter of 39 meters. The symbiosis between the two subjects was sealed in 1993 when physics and astronomy became the School of Physics and Astronomy. And inside that, the Institute for Astronomy continues here at the observatory at the forefront of research in cosmology, extragalactic astronomy, and star and planet formation.
Professor Peter Higgs won the Nobel Prize for Physics in 2013.
Let me tell you a little about my personal story of how I came to be involved in this kind of work. It really goes back to my high school days in Bristol in wartime. It so happened that I was at a school, Cottam, now called Cottam School in Bristol, which had a rather distinguished former pupil. Paul Dirac, who was one of the founding fathers of quantum mechanics, had been a pupil there about a quarter of a century before I was there. And I learnt about him in my earliest days at that school, and he was probably at least part of the inspiration for me to find out more about the kind of thing which he had done. I'm a theoretical physicist, That's to say, my skills are mathematical and conceptual rather than practical. And the term theoretical physics is a comparatively recent one in the history of physics, dating from the last century. If you go back to Maxwell's publication of his electromagnetic theory in 1865, Maxwell would have called himself a natural philosopher, which was the term used in those days for that sort of activity. As time went on, by the time we get into the 20th century, the natural philosopher had been displaced by physicist as a more precise description. And in the 20th century, the complexity of the skills involved both in theory and experiment were beginning to be such that people specialized more to be mainly theorists or mainly experimentalists. And certainly in particle physics, by the time you get to the present day, it's very rare to find anybody combining the two. Of course, the two kinds of skill are complementary. It's no good having a theory if the experimentalists don't verify that what you're talking about isn't nonsense. And sometimes the theorists are ahead, sometimes the experimentalists are ahead, if you go back in history. 50 years ago, when I did the theoretical work for which I'm now known, the things which those of us who were theorizing in this way were talking about were such that the experimental confirmation was really in the distant future. It wasn't known even whether it would be feasible, and it's taken nearly 50 years for the theory to be verified in all its features, finally culminating in the discovery of a particle at CERN on the Large Hadron Collider in 2012. I spent a week in Stockholm for the Nobel ceremony, came back with the original of this medal, and returned to Edinburgh completely exhausted.
Our last port of call is to Professor Arthur True, who's current head of school.
Physics was first taught to only the very best art students in 1583. It's therefore one of the oldest subjects that was taught at the university. And in the Chair of Natural Philosophy, we have one of the oldest and most prestigious chairs in the university. I'm sitting next to the desk of one man who held that position, the Nobel laureate Charles Barkla. Since Barkla's time, the school has flourished both in terms of scale and quality. Over the past 3 years, we've increased the number of academic staff by almost 30%, and in the most recent REF exercise, we were judged to be the third best physics department in the UK. The research excellence is matched by interest from students. We take in over 150 undergraduates each year, and in total we have almost 150 postgraduates, researching subjects as diverse as cosmology and active matter. With all of this activity, the future at Edinburgh looks really bright.